Hey Math Kids, today we're in 4.AC and we're going to talk about independent events. Just a quick reminder though, basic idea of probability is what we want divided by the total, and so this may show up throughout this. Independent events are two events that don't affect the outcome of each other. So for example, rolling a dice and flipping a coin. So if we roll a dice and we end up getting a 6, the fact that we got a 6 doesn't affect whether we get heads or tails on the coin. So those are considered independent events. And if we have two events that happen to be independent, then they follow this pattern. We take the probability of the first one happening, multiply it by the probability of the second thing happening, and that should be the probability that they both occur, or their intersection. Okay, so let's put this into practice. Let's say P of A equals 1/3, P of B equals 1/2, and P of A intersect B equals 1/6. So we want to test if these are independent. Okay, so what we're going to do is we're going to multiply the individual probabilities together, and that equals 1/6. So 1 times 1 is 1, 3 times 2 is 6. And since this equals that, then we say that these are independent. Okay. Now, what if we had P of A equals 1/3, P of B equals 1/5, and P of A and B equals 1/7. Well, we take these, we say 1/3 times 1/5, and that's equal to 1/15. Since those don't equal, we say that this is dependent. Okay? Alright, that's the basic idea of independence. So let's try a few more. So I'll just read a story problem and write down the important parts. So it says, Kim wants to know whether or not driving scooters and riding rollerblades are independent events. 20% of the people in her town ride scooters, and 60% ride rollerblades, and 12% do both. Okay, so all we have to do is take this, multiply it by this, and see if it equals this. So we're going to say, make sure you turn it into decimals though. So 0.2 times 0.6, and then we're asking the question if it equals 0.12. Okay, so if you need to, you might already know the answer to this right now, but if you need to, pull out a calculator just to make sure decimals work out the way we want them to. So 0.2 times 0.6 equals 0.12. So this is true, and so that means that those are independent events. Okay? Now, I'm going to try one of these Venn diagram problems. So we're given a Venn diagram to start off with. The intersection is X, and then we're told that this is 0.13 and this is 0.15, and we're told that they're independent. So we're not trying to prove that they're independent. It's actually told to us that they are independent, and we're just trying to find the probability of their intersection, or we want to solve for x, essentially. So we know that we have our independent formula. So we're going to just plug things into that. Now, the part that's kind of tricky for some kids is that A is the entire circle of A. So A is actually 0.13 plus x. And then similar thinking on B, it's the entire circle of B. So it's 0.15 plus x equals, and then the intersection of x, or the intersection is just x. So now it just comes down to an algebra problem. So we multiply these together, pull out your calculator to help. So we say 0.13 times 0.15, we get 0.0195. Then we do this times this, which is going to be 0.13x. This times this, 0.15x. And then x times x is going to be x squared. And we're still equal to x. Now, because we have an x squared and an x and a constant, and then we have other x's, that means that this is going to be quadratic. So the strategy that we're going to do is we're going to have to get everything onto one side. So I'm just going to subtract this x onto this side, and then I'm going to reorder things. So I wrote my x squared first, and then I need to combine all of these. So I'm going to say 0.13 plus 0.15 minus 1, and that equals negative 0.72. And that's how many x's we have when we combined all of those. And then we just say plus 0.0195. And this is equal to 0. Alright, now we're going to pull out the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And so we plug in, our a is 1, b is negative 0.72, and c is 0.0195. So I definitely use a calculator on this, but I'm going to get 2 times 1 on the bottom, and I'm going to get the opposite of b, so that's going to be positive 0.72. b squared is going to be negative 0.72 squared minus 4 times a times c. Alright. So the bottom of this is just going to be 2. Negative 4 times 1 is going to be negative 4. And then negative 4 times that number, negative 4 times 0.0195, we get negative 0.078. And then we also need to do negative 0.72 squared. .5184, and then we combine those, and that's what's going to be under our square root. So we just need to subtract from the previous answer, subtract 0.078, and we get 0.4404. So we have 0.4404, that's under the square root, plus or minus 0.72, and this is all over 2. Alright, we gotta keep going. So we're going to square root that number, or raise the previous answer to 0.5 would be the same as square rooting. And so we get 0.6636 is what I'll do. 0.6636. There's a plus or minus. There's a 0.72, and that's over 2. Now we need to take both these answers. We need to do 0.72 plus this number divided by 2, and then 0.72 minus this number divided by 2. So going back to the calculator, we do 0.72 plus 0.6636, enter, divide by 2, we get 0.6981. Or 1/8, whoops. And then we do the minus one, so 0.72 minus 0.6636, enter, divide by 2, we get 0.0282. Okay, so those are the two values of x that would make this true, and sometimes that happens. So for those to be independent events, there are two percentages that could overlap. Now, on your homework, there might be a negative answer. If one of these ends up being negative, then you're going to throw out the negative answer. Since both these are positive, they're both viable answers, and so the intersection could either be about 69% or it could be about 3%. Okay? If you need additional help, please come to Math Lab, but until then, calculate.